a book and a paper over here. So now the book and the paper are the same thing. Now, if you look at your book, right? Sorry, just let me how yeah. It's the first one is Fairview Methodist Girls' School. Yes, you will have the same outline, but just that the grid is a bit off. So what I've just done for you is that I've just printed out for you in a the one with the better grid. So you can just use that. Actually, it's the same thing, exactly the same thing. Okay. So today we will be going through our mock exam papers. This is to get you all ready for it. So you all need to ask me 101 questions. Some of you have joined me since January, right? This class started in January. So I have not gone through some of the topics with you all. So just ask me 1,000,001 questions. Okay, now let's just begin the class proper over here. Now, I know some of you are very excited. You all know what to do with when you see a cumulative frequency curve. However, can I just want to share with you all something? Make sure we are all aligned. Now, in our cumulative frequency curve, one of our first point over here is known as our 0 percentile. So this is our very, very starting point. Okay, so one of the very significant points you have over here is your 0 percentile. Now, if you go all the way up until the maximum of this curve over here, which in this case is over here, this is known as your 100 percentile. Okay, so this is how we name things in our cumulative frequency, our 0 percentile and our 100 percentile over here. Now, on top of these two different percentiles, right, there are three more which is of interest. Okay, the first one is of interest is this link known as your 25th percentile. Now, this 25th percentile has a very, very special name. This is known as your lower quartile over here. Okay, so this one is your lower quartile. Now, in order to find out which student, right, will fall on the 25th percentile, we will just take 25%. Okay, in this case 0.25 multiplied by the number of students that we have, and then in this case, right, I can find out that this is the 20th student. Okay, come Donovan. Donovan, take a set of this one and sit wherever you feel more comfortable with. Okay, you can sit in front of cursing or wherever you feel more comfortable. Okay, so this one is your 25th percentile over here. So now the next thing that we are interested in is this thing known as your 75th percentile, which is known as your upper quartile. So again, this is not difficult to go and find out. 0.75 times 80. This is your 60th student. Okay, this is your 60th student. And your last one over here, median means your middle value, right? So in this case, this one is your median over here. Now, what we are doing over here, right, for this, all these, how many points I have? 1, 2, 3, 4, 5, right? All these five points over here, these are known as your positions. They are not the actual lower quartile, upper quartile, or your median. How do you find your lower quartile, upper quartile, and median is to find out the corresponding values when you draw across and down from your curve over here. So very, very easy stuff. So position and the value itself is different stuff. Okay, they are totally different things. Okay, now, so 1, 2, 3, 4, 5 over here. Now, let's take a look. Over here, the question is asked to estimate, right? So in this case, right, remember, when you are seeing all these kind of words in our stats over here, this means to say, right, there is no exact values. Okay, the reason why there is an estimation over here, can you all write this down? This is because there is the individual values over here are unknown. Okay, the individual values are unknown. That's why we are trying to estimate this one. Okay, so if it's known, this will be known as a distinct data. But for our cumulative frequency curve, okay, just one more information for you to go and highlight. This is a continuous data. This one over here, this is known as your continuous data over here. Okay, so a lot of things to unpackage, right, for our this particular question, which is continuous data. This is an estimation because our individual values are unknown over here. Okay, so now, first one, you all can use whatever colors that you have available. Let's go and find out our median value over here. So again, there's a difference between median position and median value. Can everybody try to go and find out what is your median value in this case? Okay, and then we'll just see whether we match. So go across from 40, go all the way straight down. In this case, this is somewhere around here. Okay, Just go all the way down. I think it should be here. Okay. Okay, now what I am reading off from my graph is this. This over here, this is 53.5 marks over here. Now, do we get the same answer? Got up. Okay, so in this case, my median value in this case is 53.5 marks over here. Okay, this one quite easy, quite straightforward. Okay, now, next one. I want to find the 70th percentile. So let me just ask Kira. Kira, how do you go about finding out what is your 70th percentile? First and foremost, what should I be doing? Yes, okay. So I want to find out the 70th percentile position, right? So 70th percentile position. Okay, and we're looking at the position over here. I want to find out how many students, right? So how do I go about this? Yes, thank you very much. 0.7 times 80 over here. Quick math, what do I get? Yes, this is the 56th student over here. Okay, so 56 students. So can everybody go across to your graph over here? Go and find out where is 56. In my case, I have 1, 2, 3, 4, 5, 6 over here. It should be somewhere around here. This is 56. Okay, you can use whatever color. For me, I can be very, very colorful, but if you only have one color, then so be it. Okay, draw it across. And in this case, okay, Donovan, can you give us what is the value to get for this one? 60.5. The rest of you all got 60.5. What do you get, Kira? 61? 61.5. How are you? 61. Yours? 61. Davina? 61 also. I also got 61. Okay, so over here, let's go with 61 because I got 61.5, 60.5. So in this case, right, position and value is different. So my 70th percentile over here, this will be equals to what 61 marks, right? 61 marks. So students and marks, totally different stuff. Okay, totally different stuff. Is y-axis always the position? Yes. I think I have not seen any cumulative frequency in which the position is not the vertical axis. Yes. Okay, yes, very good question. But I have seen before a cumulative frequency that looks like this, which I hope you all don't see it. This is a nightmare. Okay, this is a reverse cumulative frequency curve. Okay, come. Next one over here. Let's take a look. I want to find out what's the interquartile range. Okay, so let's get Haoyang to help us. Haoyang, a few questions for you. What is interquartile range? What is IQR? Okay, this is a short form is IQR over here. What is IQR? Okay. Yes, upper quartile minus lower quartile. Okay, very good. Now, there is something special about the interquartile range, right? So can I ask Davina? Davina, do you remember anything about interquartile range? What does it measure? Not too sure. It measures something, sorry? The difference, because upper quartile minus lower quartile, so different, right? Okay, something to do with difference. Something to do with this thing called, it starts with C, it starts with a C. It measures this one, start with C. O. No, N. No, S. Still no, I. Still no. Audrey got it already, Audrey? Yes, consistent. It measures consistency over here. Okay, go and write down measures consistency. So upper quartile position and lower quartile position is different from your lower quartile and upper quartile. Okay, can everybody please go and find out what's your interquartile range over here? Okay, I will go around the class. I will help you all. Just so you'll be able to find out upper quartile, lower quartile, the positions are as such. Okay, come everybody, let's go. Okay, come. Here's around. I think of whatever is necessary. Oh, what is that? Okay, let me know what's in. Upper quartile minus lower quartile. Okay. Okay, yes, 19 what? What is the difference? 19 what? Students, marks, people, 19 what? What are we talking about? Okay, very good. Okay, I'm going to find out my upper quartile. Forty-one, 42, 43, 44. 63.5. Okay, you should be getting 63.5 and 44.5. Okay. Unless my graph and your graph, unless the printing is different from my graph and your graph. Do you get that? For 63.5 for my upper quartile, 44.5 for my lower quartile. Or no. 64. Do I got 64? 64? What do you get? 63. 63 what do you get, Audrey? 64. 63.5. 63.5. How about yours? I haven't do yet. Okay, okay, haven't do 63. Okay, this is based on my drawing over here. See, right? Go straight. This one in the middle. So if it goes in the middle, it's somewhere around 63.5. Okay, okay. So for consistency sake, everybody, can we do 63.5 and 44.5 over here? Can we just for consistency sake, can we just do this? This one will be equals to 63.5 minus 44.5 over here. In this case, this one will be 19 marks, right? Okay, can we just do that? Okay, so everybody has the same answer. So interquartile range measures consistency over here. Now, there's something about interquartile range. Donovan, I don't know if you remember, if my interquartile range is very, very big, what does it tell us about consistency? Less consistent. Okay, more consistent. Less consistent, right? Yeah. Opposite one, right? Yeah, opposite, right? So if my interquartile range is very, very big, this one over here will be less consistent over here. Also, I also mix up less consistent over here. Yep. Okay, this one is the opposite of each other. If it's big, then that means it's less consistent. If it's very, very small, that means it's more consistent. Okay, opposite of each other. Okay. Now, any issue so far? Interquartile range, upper quartile, lower quartile, median, 100 percentile, 0 percentile over here, continuous data, so on and so forth. No, okay, very good. Now, the top 10% of the class receive a gift from the teacher. What is the minimum marks to receive a gift? So let me rephrase it. Let me rephrase in such a way that it is easy for us to understand. So the top 10% means to say from which percentile to which percentile? Audrey. Okay, I repeat the question. The question is, if the question say that top 10% of the class receive a gift, right? So which percentile are we looking at? Which percentile to which percentile? Sorry? 0 to 90. How come that one top 10%? That is the below 90%. Huh? 0 to 10. That is the 10% worse one. 90 to? Thank you very much. Okay, so over here, when we are talking about top 10%, we are talking from the 90th percentile. Okay, let's talk in their language, right? 90th percentile to your 100th percentile. Okay, this is what we're talking about. This is the 90th percentile to the 100th percentile. Now, let me then ask the next question, right? To follow up with this question, Ke-Sing, how many students are in the top 10%? So if I want to find the number of students, okay, that in the top 10% over here, what will you tell me? How many students do I have in the class? 10% times 80 over here. So 10% times 80. So 10% of 80 over here is 0.8 times 80 is 0.8. 0.1 times 80 over here, which is equals to 8 students. Okay, so 8 students. So what I'm doing, right, is that I'm counting down from my 100 percentile to my 90th percentile. So if we go back to our curve, we are looking at this, which is your 100 percentile, and then I need to count 8 students down. So in this case, over here, okay, I try to make it very nice for everybody. Okay, from here to here, there is a total of 8 students. Okay, so 72 is the 72 students will be the 90th percentile. So can we draw a line across? Okay, now I want the class to give me your answer. I think we should have the same one. It is in between a box, right? So can somebody shout out what's the answer? What do you get? What's the minimum marks to score to get for the top 10%? What do you have? 66. 76, huh? 76. 1, 2, 3, 4. What do you get? What do you get? What do you get? 75.5. 74.5. What you found? 74.5. How about you? 74.5. Not too sure. Okay, Davina, you have to go and check your eyesight. Davina, I think you need to get new specs already. 74.5, we go all the way straight down. Let's go and take a look. I also got 74.5. So let's just go all the way straight down here. It's in between the two values, right? So what I have here will be, this is 74.5 marks over here. Okay, very, very good. Okay, so this one is just a zoom out. You can just go and write that there's 74.5 over here. Now, final question. Find the probability that the student chosen at random has at least 40 marks over here. Okay, I like that number. So let's go with Kira. Since Kira is already done with this question, Kira, how do you manage to do this? Do this particular question? Wait, let me just write this one first. Minimum marks. Minimum marks over here. This one should be equals to 74.5 marks over here. Okay, now question C over here. Let's get Kira to explain to us. How do you do this question? What is your first step? I need to find the students. Okay, so how do I find the students from here? Use the graph. Okay, so that means to say if I'm using a graph over here, where am I looking at? 40, huh? Okay, come very good. So let's go all the way up from 40. And then in this case, right, it should be touching somewhere around the, it's quite nice one. Is it quite nice? Okay, let's put it this way. Okay, this one should be around like that, right? 13. Okay, now I'm gonna get Kira to help me to explain. If I read 13 over here, this 13 means what? What does this 13 students mean? Very good. So what Kira essentially is saying is this. There are 13 students who score 40 marks or less, right? So Kira is saying in order to find at least 40, I need to take 80 minus 13 over here. Yes, thank you very much. So this is 13, right? Can we go back to our this question over here? I want to find a probability of students at least. So number of students, okay, my number of students who scored at least, this one is at least 40 marks over here. This is equals to 80 minus the 13 that we have just found. So this one is equals to 67 students. Okay, that's just 67 is enough already. 67 students. Okay, because I already put the title number of students, 67. Now, the final probability, right? So we are only choosing one person. Remember, probability is the favorable outcomes over the total number of outcomes. So my probability that the student score at least 40 marks over here is 67 over what? Yes, 80 is the total number of students. So this one will be my probability. Now I cannot simplify, right? This is the simplest form already. Okay, so I just leave it as it is. Okay, are we okay so far? So a cumulative frequency curve is something in which we need to be very comfortable with a percentile, lower quartile to find the position, the value, and so on and so forth. Okay, so sometimes it will include some probability somewhere, somehow. Okay, now, any question from the class? Okay, scanning from, okay, no questions. Okay, let's give Chawan a bit while to go and copy down whatever that is necessary. Okay, really no question for CFC? If no, can everybody take a look at the second question over here? This one is your standard, very, very standard way of asking about corrected mean and corrected standard deviation. Okay, can already? Okay, now let's take a look at our question 2 in this case. Okay, let me just erase this. Now, the question reads this way. David recorded the times of 12 runners for a 2.4 km run. The mean time, by the way, if you forgotten what is mean is your average of the runners was 13 minutes. Standard deviation of the runners was 2.55 minutes. Okay, now, again, standard deviation is another way of saying the consistency, right? I try to tell you about the consistency over here. Now, standard deviation is the deviation from the mean. Interquartile range is the deviation from the, not too sure, deviation from the median, right? Yes, deviation from the median, right? Okay, so we have mean time and standard deviation over here. Now, the question then says the recorder that David used was found to be faulty. The correct time for each runner was 2 minutes less than what David has recorded. Write down the value for the corrected mean and standard deviation over here. Now, why do I have this over here? Okay, I have this over here to show us the difference, right? Or rather, to compare between my interquartile range, okay, your interquartile range and your standard deviation over here. Now, I know that we have done this before because I explicitly talked about this. Now, your interquartile range is the deviation from the median, okay? And we know that this portion over here is 25%. We also know that here is 25%, okay? Now, your SD, which is your standard deviation, is the deviation from your mean over here. Okay, this is the deviation from your mean. So what is the similarity between them? The similarity between both of them is this. Both measures your consistency over here. Okay, both of them measures consistency. Interquartile range measures 50% of your data, whereas your standard deviation measures 68% of your data over here. Okay, now that is their first difference, right? The second difference is when is it appropriate to use interquartile range and when is it good to use our standard deviation. So interquartile range versus my standard deviation over here. Now, I do not know whether you all still remember this, but can I just get the class to kind of just to go back to whatever we learned thus far, when is it good to use my interquartile range? When is it good to use my standard deviation? Do you guys remember? We talked about this before. When is it good to use interquartile range? It's something to do with this word. Something to do with this word. Yeah, so when is it good to use interquartile range? When there's outlier or when without outliers? Outliers, right? So when is it good to use interquartile range? Is it with outliers or without outliers? When there's outliers later. Huh? Without. Bro, okay, this one is with outliers. So interquartile range, your IQR over here. But good try lah. Okay, good try. At least you got to try. Okay, interquartile range is very good when there when there are outliers. Okay, so outliers are extreme values. Remember, we talked about this before. Extreme values over here. Now, because I'm just looking at my the central data, right? I don't care whether the extreme values is 0 or 100 or whatever it is. I'm just looking at the middle and then from there 50% out, right? So that's very good when it's your outliers. But standard deviation is very different. Standard deviation includes everything. Now you don't have to copy the data, don't have to copy the next part, right? I just want to show you that your standard deviation over here is this formula. Okay, by the way, this one will be given exam, so you don't have to worry about this. This is minus your mean square over here. Now, you see, all the data is included. So because all the data is included, right, when you have outliers, right, it mixes up your standard deviation. So if that's the case, this is not good when there is outliers. Okay, it's all wrong. Outliers, no good. Okay, so this is the two things that you have to take note of. Okay, now, so yes, a lot of things before we start the question, right? So this is to cover all grounds. Now, if I ask Davina, right now I have 12 runners. Their mean time is 13 minutes, but there was something faulty in the recording system. So if I ask you to tell me what is the corrected mean, what will you tell me? Not too sure. Not too sure. Okay, hey, now let's stick with I'm gonna show you all an exam strategy which will help you. If you're not too sure, I changed the question a bit. Now, Davina, now I have 5 people over here. 1, 2, 3, 4, and then I have 5 over here. Okay, I have 5 people. Now their running times is 10, 11, 12, 13, 14 over here. Okay, now let's use median as our performance indicator. So the median over here is 12 minutes, right? So let's say, for example, if my recorder has something wrong and everybody is 2 minutes lesser, so -2, -2, -2, -2, -2 over here, what happens to my corrected median? -2. So the same thing happens when it's for mean, right? Mean is your average over here. So if everybody -2, my corrected, so we are back to this question over here. When we are back to this question, my corrected mean over here will be 13 minutes, but I need to -2, correct? So -2 over here, which is equals to 11 minutes. Okay, does it make sense to you all? Because it's faulty, right? So everybody also reduced by 2 minutes. So that means to say my mean, my corrected mean over here will be -2. Okay, now same example, right? If I go back to the same example, now I want to find another person, which is Donovan, to help me. Donovan. Now, we go back to this very simplified understanding. So if I'm talking about interquartile range, right? Okay, the reason why I'm using median and interquartile range, right, is because there's some similarities. Now, interquartile range is a difference between this part over here, right? So the difference between these two is 2 minutes. Agree? Okay, now, Donovan, now everybody reduced by 2 minutes over here. Will my interquartile range -2 or stay the same? Stay the same. So in this case, right, the same thing, my standard deviation, my corrected, right? My corrected, you don't have to put the approximate, it's just to show you, corrected standard deviation over here will be still 2.55 minutes because this remains the same. Okay, it remains the same over here. Now, why am I going through all this trouble? Because in your exam, you will encounter stuff like this, some strategies to which you can use to help you understand the question a bit more. Okay? Okay, thank you very much for the response, class. Very, very loudly, I heard. I was like, wow. Okay. Okay, come, let's go on to the third question. Okay, third question over here. Let's go and take a look. Okay, and I think I'll let you all try this by yourself. Now, the 12 hours pollutant standards of a city were recorded as follows, okay? Above data is represented by the box and whisker diagram. Okay, now let's get Qiao. Now, Qiao, there are 5 points in which I'm interested in. This point, this point, this point, this point, and this point over here. Now, this point over here is known as my lowest value. Can you share with us what are the remaining 4 points over here? Please remember. If I have lowest value, I will also have highest value. So this one over here should be my highest value. Okay, now the next thing, you're going to tell me what is these 3 different points over here? Something that we have also done in our cumulative frequency curve. This one is, just remember, start with L1. Yes, thank you very much. This one is my lower quartile. This one over here will be my, start with M1. Median, okay, and then my final one is height. Height, where your height come from? This one over here. Start with U1. Oh, yes, upper quartile, right? Upper quartile over here. Okay, very, very good. Now, can everybody just take a look? I can very easily find out what is my A and what is my E over here. So, what is my lowest value? Somebody please shout out. What is the lowest value that I'm looking at? 17. Thank you very much, Davina. What is my highest value in this box of data? What's the highest value? Is it 82? 91 over here, huh? Okay, yes, 91. Absolutely correct. Okay, now I am stuck already because in order to find my B, C, and D over here, I should be doing something. Kira, you already have formed something. Can you share with us how do we continue from here on to find out lower quartile, median, and upper quartile? Six and 7 hours. Okay, can. But then what should I do doing first? You are absolutely correct. But thank you very much. Okay, can everybody arrange? This one is arrange in ascending order. Okay. So remember when the data is all jumbled up, please go and arrange in ascending order. So let's see, 17, 20. Kira, just correct me if I'm wrong. 26, 33. Oh, there's a 24, right? Okay, see, my eyes are not so good. Say 24 over here, 26, 33. I should start cancelling, right? 20, then my this one what? 50, right? Okay, 50 over here, 52, 56, 70. Oh, 65. Oh my goodness. This is what happens when you grow older. 65, 70, 82, and 91 over here. Okay, so I should have all the 12 data over here. Okay, very nicely. Arrange in ascending order. Now, Kira, I want to continue to push you. You say something about 6 and 7 over here. How do you get that 6 and 7 values? You say one, I never say one. You say one. So I just follow what you said. I just look. got a more systematic approach. But yeah, I can look and see. But if you see like Jefferson like that, I look, see, I also blur. So I can say maybe is it here? How do I know? Is it here or is it here? There must be some systematic approach. Cannot be I just look one. I forget the formula, huh? Okay, anybody remember the formula? Something plus 1. And then I have to divide by. Yeah, okay. So what's the formula? Yes, thank you very much. Okay, so median position over here. Median position is equals to n plus 1 divided by 2. In this case, right, I have 12 plus 1 over 2, which that's why Kira is saying about 6 and 7 position, right? So this one should be the 6.5 position. So let's go and take a look at 1, 2, 3, 4, 5, 6. So should be here. Okay, so let me just draw a line in between here. Median position and median is different thing. So my C, which is my median, is 50 plus 52 divided by 2, which is equals to 51 over here. Okay. Now, these are just PISA values, so nothing too much with this. Now, how do I find upper and lower quartile? Don't ask you already. Somebody give me another way to go and find my upper quartile. Let's start with upper quartile first. How do I find out my upper quartile? Do I just look and see? Can we don't look and see? If I look and see, maybe this one is my upper quartile, correct? What, I got 6 values, all right, in the middle should be here, right? Okay, so another, okay, 2 ways. Okay, if you want to use n plus 1, divide by 2 also okay. So I have how many data? 1, 2, 3, 4, 5, 6 over here. 6 plus 1 divided by 2. This is the 3.5 position. Okay, so another way you can do this is as such. So let me just draw a line over here. This over here is my upper quartile position. Here is my lower quartile position. Okay. So can everybody please go and try question 3 by yourself? Question 3A, B, and part 1, part 2 over here. Okay. So this is where you all just try and navigate for yourself this question. Okay, come, let's go. I will walk around and then I'll help you should you need to clarify certain stuff. I think this is my okay, can it's me. Yeah. Comment some more. Okay. Xiao En, you have to ask me question. Can you pass this to? Oh, very good question. Okay, okay. Well, why cannot go? Because this is distinct data. This one over here, just now that is done, right? This one is this one will tell you this way. So this one is numerical data. So you cannot use this method. You will find out what is your upper and lower position. So over here, we can do is cut this one up and cut this one up. Okay. Okay, let me see. Okay. Going on, let's see your explanation. Okay, I will agree with you. Okay, so the quality is relatively is low. Okay, yeah. So on the way, so yeah, 50% by not healthy. This other 50% is healthy. In this case, I think also average shot. Okay, so if I have the healthy, which is very good, right? Means this one not so good. This is bad. So 75% of time is okay is bad. Yeah, it's worse bad. Yeah, so this one is good. So how many of the 12-hour management is less than 25? One, two, and three. Out of 12, right? Those 3 hours, but then if 12 hour average. Let me look at 12 hours, 12 hours. Okay, I will expand on that. Wait, this one is here or? Okay, come. Can I just help you all to understand? Now there are some questions which I thought was very, very good. Okay, very, very good questions. Number one over here, find the percentage of the 12 hours. I think everybody got this correct. So it's 25%. Okay. Now there are two different ways in which we can address this. One is an observation, another one is a comment. So an observation is this comment on the quality of the air. Now, the observation is 25% of the time, and the air quality is in a healthier range, right? The other 75% of the time, the quality of air is moderate to unhealthy range. So that's what we calculated, right? Because over here, right, 25% is in a healthy. That means the other 75 is moderate and unhealthy. Now, this is using numbers to show an observation. Now, your comment comes in whether or not the question has defined that, oh, if it's 50% of the time, the air quality is poor. But over here, right, comment is putting in your own opinions towards your air quality over here. So because we are going on majority, right? Because 75% of the times is majority, right? So we can just say that the quality of air is poor or unhealthy. Okay, so there's a difference between your comment and your observation. Okay, now you can copy this down. I want to do something very, very different now. I'm gonna pause here for a while and I'm gonna do something with the class, the 7 of you, all right? So I just want to let you all know, right? How is it when it comes to O levels, when it comes to an explanation question? So just go and copy down whatever that needs to be copied. One's an observation, one's a comment. Some teachers will want you to include the observation part. What happened? Some teachers want you to include the observation part, which is fine, totally fine. Okay, but at the end of the day, you must be able to give your own opinions or comment about the quality of air. Is it poor? Is it average? Okay, if you want to say it's average, why is it average? Okay, but in this case, because it's based on majority, that's why we are going with the quality of air is poor or unhealthy. Okay. Okay, can I? Okay, now Can you just focus your attention on the screen? I'm going to switch to something that is not on the mock exam over here. I just want to help you all to understand what is needed for your over here. Chutomate. Features. Okay. Okay, now let's take a look at this one over here. Now, just look at this. This is just more for me to explain. Okay, they say Ravi invests 4,500 at a rate of 0.25% per month compound interest. Explain in the first year interest. Explain why the first year interest is not 3% or 4,500 or 4,500. Okay, so student 1 says that principal amount changes every month. Student 2 says that interest changes every month in his investment. Student 3 says this. Student 4 did a working. So now, this one is just based on your own opinion. It doesn't matter if you're wrong or correct. Just want to get from your ideas or opinions from the class. Which student got the point? Student 1, student 2, student 3, student 4, or a combination of both of them. So let's just take a look. Okay, give you all 10 seconds to make your judgment. Which student or which students got the point for this explanation question? Okay, 1, 2, 3, or 4. Okay, doesn't matter whether you get it correct or wrong. Okay, now let's start with Kersing. Kersing, which student do you think got a mark? 1, 2, 3, or 4? Yes, it's okay one. There are no right or wrong one, no prize one. 4, question 4, or student 4, how about you? 1 and 2. Okay, how about you, Audrey? 4, right? 4 looks good, right? How about you, Tian? 1 and 3, okay, Ken. Hao Yang, which student do you think got a mark? 1 and 3, okay, very nice. Why do you choose 1? Because it's circled, is it? Don't care about the circle part. The circle part is nothing, huh? It makes sense. Okay, can. Combine 3 and 4. So your long essay, right? So make sure you get a pass, okay? All of you. 3 and 4, right? Okay, so 3 and 4 looks very enticing, right? So as math students, because as math students, we hate to explain. So I just tell you the truth, only one of the students got it correct, and it's student 1. Okay, so the idea over here is to let you all know that yes, there are times where you are supposed to use working. The working can guide you to answer, but essentially, right, when a question is about explanation, okay, when the question is about explanation, that means to say that you need to have a keyword like science like that. Your science, your chemistry, physics, whatnot. There are some keywords over here. So keywords are essential. So when a question asks you to explain using English, right, then you have to have some keywords over here. Okay, so that's why I'm bringing up to this particular point, because over here, when they ask you to comment, right, they're looking for some keywords. Okay, and the keyword over here is quality of air is generally poor, okay, unhealthy. So that is what they want to do. Okay, so you can provide you can provide workings and whatnot, but that is just a way for you to guide. Okay, come. Can we take a look at this question 4 over here? Now, before I let you all try this question by yourself, what are what are the 2 things that we always comment about, right, when it comes to your interquartile range, your median, and what are the 2 things that we comment about? Median and interquartile range, right? Okay, so median means to say that either I'm taller, shorter, longer, whatever it is, right? So that is your performance indicator. Interquartile range is about consistency. Okay, so can everybody try question 4 by yourself? I hope you all still remember how to use your calculator to calculate your mean and your standard deviation. But if you forgot, it's okay. I have this for you. Where is this? This one over here. Okay. So can I give you all 8 minutes? Please go and finish up question 4 and let's see how well we fare for this question over here. Okay, come everybody, let's go. This one, calculator one. By the way, interval values means I use what's my x value? If I have a range of values, I should be using what kind of values? Is it my data, is it 15 or 30? Middle value, thank you very much. Use the middle of your range. Okay. Yes, very good. First middle value is 24.5. You got calculator? No problem. Okay, let me go and find. You will find me. Remember, your mean and standard deviation always correct to how many significant figures? 3. Yes, thank you very much, Davina. I can always right. Okay. 59.8 what apple, banana, orange. Minutes, right? Answer. Very good. Now we are together anyhow. Then okay like we so we try to be neutral right? Oh yeah. Okay. But thank you for including me. I like that we are part of the answer. This is the X bar, which is your average. This sigma is your standard deviation. Okay. Yes, you can look at all these answers to go and compare whether you're correct. Where's your equal sign answer here? X bar standard deviation. I'll give you, if I can give you half mark, I'll give you half mark. You know. Anyway, let's see. Yes, very good. There's a keyword. The keyword is what? Estimate. Estimate. And the exact values are they known or unknown? Unknown. Right? Exact values are unknown, right? If they are known, then you will have an exact value, right? How to do that one? Okay. So over here. You just want me to walk over here, right? That's like yes. You compare the mean to the indication. Yes. So the mean have more consistent saying right? So to compare mean to mean. This one is longer. So the mean starts to be more instead in here, right? Yeah. That's the first comparison. After you compare the mean, then this one is more than what we need to say. This one is more consistent, but I'll say more consistent than right. So you compare these two. Okay, if you are done with question 4, that's fantastic. Please take a chill pill down the hill so that we'll take a 5 minutes break. Okay, very good. Standard deviation it takes the middle of the yeah, I like your answer also. That's okay. Good. Okay, come and see. Okay, let me just take a look for those who are done. Okay, very nice. More consistency, right? More consistency than right? So instead of more consistent, more consistency. Come, let's have a look. I do that. More cars are more consistent. Cars yes, very nice. Yes, very good. Okay, for those who are done, please take a chill pill down the hill. I'm just gonna show you the answer over here. Okay, sorry, I'm just gonna show you the answer over here. You should get the estimated standard deviation as 20.5. The individual data are unknown for the means and standard deviation. That's why I estimates. And in this case, right, mean or whatever it is, right, is longer or shorter, standard deviation about consistency. So in this case, some of your answers are even better explained. So cars in shopping mall A, shopping mall A stay for a longer period of time. Cars in shopping mall stays for a more consistent period than in shopping mall B over here. Okay, so something along those lines. Okay, come, everybody, do what you can. I will mark your answers over here. Let's take a 5 minutes break. Okay, you can go toilet, do whatever is necessary for you all to recover for the next part of the class. Okay. Okay, come, let me see yours. A, B, okay. How about yourself? Parts longer forever. Okay, go longer, shorter, sorry, more B, more B is fast enough. So people. Brother, I know this is math, but then must be a bit on point, bro. Don't give me the caveman, bro. Shopping mall yeah, okay, that sounds nicer. A little bit, yeah, okay, can. I will give that one a thing. Funny, but you. What is that? Presentation now. Very good. Wow, minus 1 again. Guess why? What? Tell me it's crabs, are you? Wow, I want you. Yeah. I hope you want. As the mean in shopping mall A is higher than B. Cars are staying longer outway at shopping mall A, at shopping mall A. Okay, and here, over here. Okay, I didn't see the thing. Okay, more cars, okay. As the shopping mall B is higher, it's more consistent. Why is more consistent? The stay, right? Okay, can okay, can. Hey, Mr. Trump! Hey, you funny, are you? Huh? From last year, oh, okay. Hey, go. Break. I give you a lot break. Come on, okay. Okay. Let me see. No. Okay, come. Shall we begin? Okay, very good. Very happy. Sorry. Okay, now let's go and do this question. Okay, this one is easy stuff. Okay, now I'm gonna ask you a lot of questions since you're done with this, right? Okay, come, let's take a look at our question 5 over here. Okay, now question 5 is your standard probability one over here. Okay, your standard probability. It says that a box consists of 15 flavored identical chocolates, 8 of which are vanilla, 1 mint, 6 dark flavored chocolates over here. Victor takes a chocolate at random from the box and ate it. Or Audrey, Audrey takes a chocolate at random because she's hungry. Okay, so now over here, this is our very standard tree diagram. Okay, now the question over here, right, is very nice. They give you a legend. Okay, so if you want to use V, M, and D over here, please always remember to have a legend. Okay, but if you don't want to use this one over here, you can write it out loud. Your vanilla over here, your mint, and your dark. Okay, you can do so. Nothing wrong with that. Now, so over here, can y'all just please go and write this down? I have Victor, vanilla, mint, and dark over here. This is the probability that Victor has it. So 8 out of 15, because there's a total of 15 different chocolates. 1 mint, and then I have 6 dark chocolate over here. Now, Audrey, for Audrey's case, right, every time when Victor has taken 1, right, the total number decreased by 1. So you can see the denominator over here is 14, 14, 14. All of these are 14. This is 0 over 14, 14, 14, 14, 14 over here because Victor already taken 1 chocolate. Now, and then you just write in the corresponding values, okay, which is 7 out of 14 and so on and so forth. Okay, now this one is easy stuff. I believe everybody can do it. Okay, but you can just finish up this portion over here. Okay, now I'm just gonna once you are done with this, I'm just gonna ask a few questions from you all, and then we see how we navigate this. Okay. Okay, can I? Okay, let me just erase all of this one over here. Okay. Donovan, you managed to find out the reason why? Just on me. Okay, come over here. Now, this one is, can we just copy this down? Okay, now I'm just going to ask everybody a few questions. Find as a fraction of its simplest form over here. Now, this one, please remember simplest form over here, the probability that both Victor and Audrey ate the same flavored chocolates. So over here, let's get Kira to help us with this. So Kira, what are the combinations that we are looking at? Thank you very much. We have vanilla, or mint, or we have our dark chocolate and dark chocolate over here. Now, in the topic of probability, every time when you see the word or, this means you add together. When you see the word and, means to multiply them. Okay, so Kira is absolutely correct. So vanilla is 8 out of 15. Then I will have a reduce of it, 7 out of 14. This is one such event. All means plus together, mint and mint. Now, for some students who are very perceptive, right, they will say that, hey, mint and mint times 0 means 0. So I have to include it. Yeah. But for me, I'm just going to write it down so that you can see. This is 1 out of 15 multiplied by 0 out of 14. And then this is plus my duck over here, which is 6 out of 15 multiplied by 5 over 14 over here. Okay. So very good, Kira. Thank you very much for giving us the combination. Can you all time put in your calculator? What do you all get for this? Let's get Davina to give us the answer. And we correct our answer to Davina's one. Okay, should be correct. Okay. Okay. Davina, don't calculate the infinity, no. This one, don't calculate the infinity. What do you get? To give you the fraction. Yes, thank you very much. So we leave it in fraction, 43 over 105, absolutely correct. Okay, come. Next one over here, let's get Hao Yang. Now, do we want to find a probability that both ate neither vanilla nor dark flavored chocolate? So what does that mean? So what do they eat? If they ate neither, huh? Yes, thank you very much. So they say that we want to find a probability of them eating mint and mint over here, which is equals to 0. Thank you very much. Okay, mint over here is a 0. Now, part 3 is Audrey, right? So let's get Audrey to help us. Audrey, so since you ate this dark mint flavored chocolate, right? Can you tell us what are the combinations that we are looking at? You ate the mint flavored one, eh? So what's the first one? Dark. So Victor must eat first, right? So what is the probability that you ate a mint flavored chocolate? Huh? Okay, I'll give you one combination. Victor ate a vanilla and then you ate a mint, followed by dark and mint. Anything else? No more else, right? Mint and mint is 0, right? Yes, thank you very much. So in this case, vanilla and mint over here. Vanilla is 8 out of 15. Mint over here will be 6 out of 14, if my memory serves me correctly. All mints plus them together. Dark over here is, what is dark? 6, right? 6 out of 15. Wait, wrong, right? This should be 1, right? And then this one is 1 over 14 of there. Is that correct? Yes, okay, can. Final answer, anybody? Please shout it out. What do you get? Most probably your answer is correct. What do you get? 1 over 15. Thank you very much. 1 over 15 over here. Now, the last one over here, this one is very, very tricky. Okay, now I'm going to read the question for everybody. The question says this. We want to find the probability that Audrey ate a dark flavored chocolate given that. Okay, now everybody please go and highlight this. Okay, and go and star. When they say given that, this is known as a conditional probability. I don't think you have seen this before, but some schools, they will test this conditional probability. So they are only looking for the probability that Audrey ate the dark flavored chocolate. Okay. Now, this is the branch that when Victor eaten a vanilla flavored chocolate. So in this case, we want to find the probability that Audrey, this one is 8 dark, and 8 the dark over here, 8 the dark chocolate over here. Okay, so that means to say when we are looking at this, Victor has eaten a vanilla, so we are actually looking at this one over here. This is known as your conditional probability. So they are looking at that particular value. It's usually right, students will say that, hey, isn't it a vanilla and a dark chocolate? So this one is not one after another. They are just looking at this one over here. Is that okay? So that means to say this over here is 6/14. Does it make sense to you? Or does it make sense to Kira? Or Kira is still processing? Can. Okay. Donovan, what's wrong with this? Simple sum. Thank you very much. So in this case, this one is 3/7. Okay. Just remember this simple sum over here. Conditional probability. So they are looking only at that particular one. Okay, now, are we equipped enough with our probability? Can I just get the class to try question 6 and question 7 over here? Okay, so 2 more questions and then we'll be done with our Fairfield Methodist over here. So let me just do this. Everybody, please go and try question 6 and question 7 over here. I give you all 15 minutes. Is 15 minutes enough? I think so, right? Okay, come everybody, let's go. Yes, okay, come, let me help you. Oh. Okay, good. You are very close. I just let you know for the fun. Very good. Okay. Okay, title over here. I want to see your title. What title, So this one over here is probability to pass, right? Not really. Probability circle bracket pass in first or second one. Okay, ask yourself, what's the probability that he failed? Probability he failed is 0.2. So if he passed in the second month, means what he has to do first? He has to what first before he pass? Fail first, right? He has to fail first before he pass. So wait, if you pass in the first month, means what's the probability? 0.8. If you pass in the second month, means he has to fail first and he has to pass, right? So all means plus. Okay, thank you very much. So plus those two probabilities together. What do you get? Yes, very good. How do you do B? Very good. I give you clues about this. Okay. Are we all excited? Okay, you do this first. Yeah, I will run through it. First, I want to think about it. I don't want to steal the merits of thinking. Yes, correct, which is equals to. Plus. Yeah, correct. Good. And yes. How can I help you? This one, right? Okay, so it's just giving. So now, the this is going to go as well. Okay, very good. Now, if you pass in this, sorry, I'm if you pass in the first one, you need to say is equal to correct. Now, if you pass in the second one, you pass in generally you pass in the if you pass in those will be so in generally on the happen. Oh, you got it? Okay, very good. Yeah, you're doing well. Please, Audrey, lost because you ate too much dark chocolate, right? From the previous question, that's why you food coma. Okay, Navina, how will you explain about? So, first one, okay, January. Okay, there's two. So what's his name? Thomas, is it? Okay, Thomas in January to take this music exam, he passed. What's the probability? 0. Okay. Then next year, 2026, which is this year. In February, he passed. But that means in January, he required to wait. Okay, right. So that means to say in 2025, January, he passed with 0.8, right? Then I want to include this year's probability. So how is that? Okay, very good. I'm seeing that Michael a bit more. What is this one? I get what you got. This one is the arrow, right? Okay. I working wise, okay, answer wise, you're correct. Okay. Now, over here, what you really want to do is this one, right? This one, we will see the kind of the primary school reference we use and right. In secondary school, we try to move away from this, nothing wrong. In this case, right, if we really not down in right, I will read this very much. So you look at here, the difference. Okay, any more issues? Let me see yours. Oh, still start already, right? See. Okay. Also arrows, huh? Okay. Total number. 0. How come 0.5 equals to 12, bro? Okay. How are you, sir? Okay, okay, come. Let's wait for Xiao to come back, then after I go through question B. Let me see yours. Start with this, right? You start level 9. Let's move on. No, this one. Fine, that's the title. Okay, I know I'm very naggy, Okay, sorry for dragging this out. Okay, can. Okay, now, sorry for being so naggy about the title and presentation because I want you all to not get penalized. Okay, I want you all not to get penalized. So over here, let's start with, okay, this one, everybody understands 6A over here, correct? 6A, everybody got it. Okay, now, let's take a look at this one. So write down the probability that Thomas passes in one of the first n months over here. Now, again, I give you all strategies, and I see, Donovan, whether you can give me the answer. Now, if let's say, if I say n is equals to 5 over here, so that means to say they want to find a probability that my first month I pass. So the first month I pass, what's that probability? 0.8, very good. Now, if the second month I pass, what is the probability? That means I have to fail first, right? So that means this one, can we agree, is 0.2 times 0.8 over here, correct? Now, if the third month I pass, means I have to fail first, then I fail again, then I pass. Agree? Okay. Now, if the fourth month I pass, pass means 0.2 times 0.2 times 0.2 times 0.8 over here. And lastly, if the fifth month I pass, this will be as such. 0.2 times 0.2 times 0.2 times 0.2 times 0.8 over here, correct? Now, this is provided by n is equals to 5. So that means they want to find a probability that either is here, 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 or here. Agree? Correct, right? Okay, now in any of these months over here, if we are looking at just the how to do it, can we agree? This portion over here, if we are looking at it, the formula will be 0.2 raised to the power of n minus 1 times 0.8 over here. Agree? Right? We are looking at a specific month, right? Now, if I want to find out this plus this plus this plus this plus this over here, can I rephrase the question? I want to find out the probability that Thomas passes the audition in at least one of the first n months over here. Now, what is the key thing every time we hear at least? There's a technique. Every time when we see at least means to say what? Thank you very much. 1 minus something, right? So I want to find out the probability that he passes in one of, okay, let me spell it properly. One of the first n months, which means to say I'm taking 1 minus the probability that he what? 1 is the total probability. I want to take 1 minus the probability that he... Yes, he failed in all the n months, right? That means he failed in all the when he failed in all the n months over here. N months over here. Right? Okay, so if I rephrase it this way, right? Can I ask the class, what should the expression be? 1 minus what? Fail is 0.2, right? And then what? To the power of? To the power of? N minus 1, huh? This one is n, right? That means he failed all the way. He can't fail. So it doesn't matter what is it. So 1 minus the probability that he failed in all those months means to say that the probability that he will pass in with probability that he passes, right? Passes in one of the first n months over here. So this over here is encompassed in this expression over here. Remember, at least means to say, let's say, for example, if I want to find out at least one of the flowers picked is yellow. So I take 1 minus the probability that no flowers picked is yellow, correct? Because I'm eliminating all the other probabilities that has to do with passing. So in this case, 1 minus the probability that you fail in all of the n months over here. So I'll just take 1 minus 0.2 raised to the power of n over here. Does it make sense? Okay. Okay. This one is one of the hardest probability question. So give yourself some time. Give yourself some time about it. You can sit on it. If you still don't know, later we can go and go through this again. Okay. Okay. I give you some time. Okay. Now let's take a look at this one. Over here, I know I've been very naggy. Probability that is a blue one over here is simple. This one is 0.15. So that is well and good. Now, again, I want to share with you all how to deal with units over here. Now, what you have learned in your primary school is this. Okay, primary school, they will say that 2 units is arrow, this one maybe like, let's say 80 marbles. Let's say. Okay, so 1 unit is arrow 80 divided by 2, which is equals to 40 over here, right? That's what you learn in primary school. Now, nothing wrong with that. Now, in secondary school, why arrow is not allowed? Okay, arrow over here, if you have taken A math, this denotes, if you have taken A math, this denotes limit. So that means, let's say, for example, x approaches infinity, x approaches 0 over here. So in this case, right, for secondary school, we don't use arrow. Okay, just so you all know. For those who have done A math, you will have seen this portion before. Okay, so arrow denotes limit. Now, because of that, right, our marking system will be as such. We are all using equal sign over here. Equal sign over here. So how I would do this question, they say there are 12 more green marbles than blue marbles. So some of you managed to find out the probability of the green minus the blue over here, which is good. Okay, so if you tell me that the probability between green and blue over here is 0.15, that's fantastic. Now, this 0.15 is equals to the difference, which is the 12 marbles, divided by the total number of marbles. Okay, now 0.15 is equals to 12 over here, so total number is 12 divided by 0.15, which is equals to 80 marbles. Okay, so just tighten up the presentation part. Arrow denotes limit. That's why in secondary school we cannot use arrow, but in primary school it's okay, because primary school we have not learned anything got to do with limits, all right? Okay, so that's pretty much it. Okay, now this is a mock exam for your probability and your stats over here. Can we all just go through whatever that needs to be go through? Any questions for this mock exam? Okay, I know you're very shy. I know you're shy. Because this class very introverted. You like don't dare to ask questions. So if you want to ask me a question, you can ask me outside of class. You can ask me via Telegram also. Okay, I will answer them accordingly. Okay, now with this, right, we should be transiting over to the second mock exam. This one, can I give you all as homework? But with the remaining 20 minutes, right, can you all go and finish up whatever that needs to be finished up for your second Fairfield Methodist Secondary School? Okay, can you all please go and try that? I will go around the class to go and help you out. Let me know if there's any issue. Okay, come everybody, let's go. 20 minutes, own time, own target. Yeah, just finish. Yeah, finish in class whatever that you can finish. Mhm. Mm. Wow, brother.
Which one does the software?
Yeah,
Still
but
correct.
you're still correct, yes. Yes, still correct. That's why it's more important, right? My effort lah. Effort. Okay, continue your right. Yes, how can I help you? Yeah, that's correct. Yes, you're on the right track. Please make calculate. Yes, correct. Oh, okay. Over, yeah. Let's say that I'm on the top of so one time going to be yeah, okay, can. Very good, very good. Okay, this one is correct. Okay. Yes, So it looks like there's two ways to do this. I don't apple, alright, or I can take one, probably that same thing. Right? This one, yes. Well, you go to that one, huh? That one is okay. How you know? X1. Why you use why not? So a bit is X number. I changed a bit. Check it out. Sister, this one is the quality that he chose to eat. So after he means to have already. So that means 9 out of 70 times this one over here. So this one okay. So if I have 9 44, then 9 out of 70 I choose 3. Right, you already makan already. This one you eat the sweet already. Yes, correct. So 9 out of 70 times. He makan already, this one. So this one means he already eaten already. So he was choosing. Then there's 9 out of 17 already, so he eat one. Now what is left is this one. So Lin will be eating, Hardy will be eating this one. You get me? Okay, so right. Hardy can okay. Then so Hardy is on the Lin is fun, right? So apple means lemon apple, apple, orange apple. Okay. Okay, 8 more minutes. Try to finish as much as you can. X minus 1 is good. 17 minus 6 is correct. What comes up? The rest are red. I have a total of X number of this one. So what is an expression in terms of X for it? Yeah, okay. So probably you're choosing a red marble. Red is this one, right? So if I chose one red marble, I write here, okay? So if I choose one red marble is this one, right? This is the probability of choosing one red marble. What is the total number of marble? So if I want to choose another red marble, the number of red marble will reduce by 1, right? So this one over here, x minus 1 over there. So if I x minus 17 minus 1 over here means it's equals to let's go. Quadratic equation. Yes, you have to go and cross multiply. Yes. Apple, right? So this one I know yes. However, very long and then. So why don't I just take 1, which is the total probability, minus the probability of the same flavor suited. Let it be something equal. If I have 1 minus 4 here, also figure it for that. Right? Yeah. And one of some one. But nothing wrong with the calculation. It's one. Okay. How come you want always one less? Oh, okay, you meant to put okay. Okay, very good. Then you got to be damn it. And start oh yeah. So here you're running. Yes, yes, you're right. Why don't you take 1 minus 4 to be that I mean both blue? Isn't it better? Right. Oh, you got that. Okay, can. Okay, to okay, inside okay, pass, what's that? Yes, very good. Let's see. Pretty fine. Also, okay, sounds correct. Okay, you get it? Yes, correct. That's absolutely correct. Okay, very good.